regression and linear regression.
Sir, in logistic regression, the data is in binary form. Yes, no, 1, 2.
Okay.
The output basically.
Okay. Okay. Good. So when we are talking about outcome or response variable or the dependent variable, Ansika is telling that is in binary. Can it be in like not only in binary? It can be in other groups. Can you run regression, logistics regression?
No,
If
sir.
rather
So
than
it will be in binary only, sir. 0 or 1, true or false, male or female. It will not be more than that.
okay.
So because if we want to find out for more than 2, so we can only predict the chances of occurrence of whether out of the one what will happen. For example, if we are trying to predict that whether tomorrow the stock market will go up or whether it will fall, so we can find out the chances whether it will, how much it, chances of whether it will go up and chances of whether it will fall. So there will be
Okay.
2 outcomes only.
Okay, though we have not covered and we might not find time, but I'll try to show you. Yes, but it is possible to run a regression, logistics regression, whenever you have multiple groups. And groups can be again both nominal. Let's say I want to predict based on all the data available with me, your previous educational background, whether you have taken engineering or non-engineering, how much you have scored 10, 12, all those data, then how you have been performing in last 3 semesters, right? I want to predict that whether somebody will be fit for certain kind of jobs, let's say certain kind of roles, human resources, say your analytics or finance or operations. If I want to predict that, so that is method, same logistics regression, but rather than binary, we call it a nominal logistics regression, right? So nominal means we are predicting groups. So that is not that there is no order. So I just want to predict whether somebody will be like kind of will take or will be a fit for a certain functional role, human resources or whatever kind of marketing or analytics or finance, right? Then there is something when I can predict in the order also, right? If let's say I do not have your final kind of this semester marks, and based on your previous performances, right? I want to predict whether some students will be in the OEA category, right? Multiple groups, right? But I can put the order, right? I can know that because I know that O is better than E is better than A, right? Or based on your kind of health habits, food habits, whether you are doing proper exercise or not, can I predict for those of you who are healthy, those of you who are on health status, right? Who are weak or who are average, right? If I have 3 health categories, who are healthy, who are of average health, and who are very weak health, right? Immunity level is low. Can I predict that? So that can be also done through ordinary logistics regression. But yes, when Ansika and Apurva was telling about mostly we are concerned with the binary logistics regression. But if somebody asks that, can it be done for multiple groups? Yes, that can be done. It is not that we cannot do that. Explaining that becomes a little difficult because it is very easy to say that okay, whether event will happen or not. But when we are putting that into groups, other complexities come into picture, but it can be done. So there are models. So like I said, there is a course itself for most of the economic student who do MA or go for PhD in economics. There is a course itself called econometrics. So in econometrics, there are different model, probit model, logit model. So there are different models which basically kind of utilize to predict, like let's say we'll go which kind of based on your ethnicity, based on your in location, can I predict somebody's let's say income level, right? So in those kind of situations, we can kind of use a different type of logistics regression. Again, the method or the like process remains same. Only thing is that how do you explain it? So explanation becomes a little bit complex, right? But yes, to answer my question, whenever there are multiple groups, whether there are nominal groups when there are no order, or ordinal groups where there is a order, we can make those predictions using logistics regression. But out of all those, mostly utilized are kind of our binary logistics regression, right? So quickly, what we'll do, we'll run through SAS Studio and we'll run through SAS Enterprise Miner. we'll keep the output value, we'll copy that in a Word document, and next class, so and I'll try to cover as much as possible today. In the next class, we'll come back again, try to analyze the output, right? So we'll go to task and utilities. So we'll click binary logistics regression. So what is our response variable? Like she mentioned, response variable is basically our outcome variable. In case of the insurance data I have given, right? There is something called insurance claim, which is 1 or 0, whether somebody has claimed or not. So if I choose that as insurance claim, that is what I want to predict. So what I'm trying to do is based on the data available, based on the data like regarding age, their gender, their BMI, number of children, whether somebody is smoker or not, right? So based on these kind of details, can I predict? Can I say that okay, whether somebody will claim insurance or not? In last time, what you did, you were trying to kind of in a linear regression, you were trying to kind of predict the profit amount from customers or the how much claim amount from a customer, right? Because if I take this, whatever my charges means the company, how much money that company is earning from a customer, minus the claim amount. If that customer has claimed, that gives the profit, right? So you can create a model either to predict the claim amount, right, or predict the profit, right? And you created or you must have run those linear regression comparing different type of models. So in this particular case, what we are trying to do, we are trying to predict not the profit, not the claim amount. We are trying to predict whether somebody will claim or not based on the data set, based on the information available to us. So let's click here insurance claim, then event of interest, right? So this is the interesting part where you will say that which for you which is important, right? Because see, there are only two events. This is a binary outcome, whether somebody has claimed or not, right? But what is interesting to you, what you want to understand, right? I want to understand on what parameters I want to predict for when somebody claims, when is somebody more probable to claim, right? Or which are the predictors, let's say smoking or age or number of children or let's say gender, which are the parameters, which are the variables, which are the independent variables makes that person more probable to claim, make an insurance claim, right? So that's why event of interest for me will be one because there are two only, right? 0 1. 0 means that person has not claimed, 1 means that person has claimed. Link function, what is this logit function will come back. And so if you see, there is something called probit also, where that will be useful in nominal logistics regression. But in our case, logit, I'll show you what is a logit function, and I think it might have been covered in other classes also. So classification variable, I have what is my classification variables? Okay, smoker, whether somebody is smoking or not. Then
So sex will also be the classification.
yes, so that is male and female. That is again 1 or 0, right? Let me just took. So state also I can take, but I do not want to take state because I have around 22 or 23 states. It makes the model more complex, right? Let us try to build a simpler model and try to understand rather than. And I'll show you the problem when we run the enterprise miner. In case we take states as a variable, then continuous variable, age, BMI, number of children, right? Do not check charges and claim amount, right? Because see, what we are trying to predict is whether somebody is claiming or not, right? If you take claim amount, because somebody claims, then only the claim amount will come, right? It cannot be other way around. So continuous variable age, BMI children, did I miss something? Latitude, longitude again not required here. Okay, so there is something parameterization of effects. So this coding, have I discussed this different type of class variable coding? How do you category variable? How do you code? So okay, anyhow, I'll go through this. So let it be GLM coding only. Then model, main effects. So what is classification table? I think all of you might have an idea. When we have those true, positive, false, negative, all those, then we are trying to find out those sensitivity, specificity, right? So those
Yes, sir, the
classification
confusion matrix.
confusion matrix, exactly. So then there is something called generalized R square. If you know, in linear regression we have R square, but we do not have a actual R square, because in linear regression what happens? They create an ANOVA table, and based on the level of how much how much explainability your model has, divided by the total error, total kind of uh, whatever the distance, right? That gives you the uh, kind of your R square value, right? Then adjusted R square obviously based on the number of additional variables we are penalizing the R square. So that is the adjusted R square. It is not the same kind of, because here we are trying to predict the probability, right? Here we are not actually trying to find out the profit or claim amount. We are not trying to predict certain continuous variable. We are just trying to predict whether some event will happen or not. Somebody will claim insurance or not, right? So in that case, explainability of model rather than explainability, we are trying to find out the odds, right? How better we are able to predict the odds, right? So in this case, generalized R square I'll show you. We'll not get into the mathematical formulas part, but what is that we'll try to see. Then how good your model? So there are different type of test. Mostly, then again there are a lot of controversies on this H&L goodness of fit test. So sometimes it will be written GOF, so that means goodness of fit test. Multiple comparison not required. Exact test. Here also not required. Parameter estimates, standardized and exponential estimates, diagnostics, just for default plots. Again, like it is just for only for our understanding how the, what else I am missing. Okay, I think that should be okay. Okay, I think this is the last one, is the final model. So we'll explain this, what is this log likelihood and how it is being calculated. Then R square, if you see this is max rescaled R square. So uh, as long as this is good value, we can take that, but again, this sometimes shows error. Then there are three type of kind of like in your, if you remember in your linear regression, that you have only one test, F test, right? ANOVA table, then F test. Here actually for goodness of it, we have three type of different tests. Then what else? Okay. Okay, then how to kind of interpret this, right? So this, can anybody interpret what does this age variable mean here? Like in linear regression, we used to interpret, right? If age increases by 1 unit or 1 year, what is the impact of age on your let's say whether somebody, how much profit I'll make or how much claim amount will be there, right? Or if a number of children increases, what is the impact of that on somebody's problem for the company on profit or claim amount, right? So that's what we used to interpret. So in this particular case, from this table, how do I interpret, let's say, age? So what does this number say? These estimates, all these numbers, what does it say? So these are all significant because less than 0.001, right? So that means all these variables. Intercept I'm not interested in. I've taken this variable calls. Okay, I think this it has removed. In the final model, if you see, gender is not there. Age, BMI, children, and smoking. So these are the four variables, dependent variables, which have an impact on your, independent variables, which are impacting your dependent variable, right? So how do I interpret this? Right, in linear regression, it was a little bit straightforward. If I say that, okay, there is some unit change in keeping everything else same. If there is one unit change in, let's say, age, there is some changes in your profit or claim amount. So what I'm going to say here, age, BMI, children, these three are
Sir,
continuous. Yeah.
sir, I'm not sure, but if we change the age by one, then there is a probability of 0.0284 that the person they will be a smoker.
There is not, we are not predicting smoking, right? We are predicting whether somebody will claim or not, insurance claim.
So there will be a probability that that person will claim. There is a 0.0284 probability, or maybe by 2.84% that that person will claim for the amount.
Okay. Yes, here we actually were not estimating a such probability. What basically we're saying, we are saying close to that. So we'll see the relationship between probability and odds. Odds is the ratio of probabilities, probability and probability of event happening and probability of event not happening. So here what I say, if I increase age by 1 unit, I go to this exponential of estimate. If it is greater than 1, right? So that means it has a positive impact on the kind of claim. If it is less than 1, that means it is a less than impact, less than 1. 1 is 100%. So here I can say that for 1 unit increase in age, the odds of somebody claiming a insurance increases by 0.29, means 2.9% or 2.84%. So here we are much more interested in the odds. How much odds are increasing or decreasing? Same thing if I say for, let's say, children. How will I interpret that? If for unit, no, one like kind of number increase in children, right? My odds of claiming, odds of making a insurance claim is reducing by how much? 60, not 67, 70, 5.9%. So because if you see, the estimate exponential of estimate is 0.241. So that means if the normal is 100%, standard is baseline is 100%. For each unit increase in children, you are reducing the odds by 675 point, because it is showing 0.241, right? 1 minus 0.241, that is 0.759. So by that much amount, your odds of somebody claiming a insurance is reducing. That means, so now if you see like how a company will take that kind of this kind of, if they're not running on the linear regression, so they'll try to give the insurances with people who have more number of children, because they're claiming they might become more health conscious, or they might take good care of health, good care of when they're driving car or driving vehicles. So in that case, what happens? The odds of somebody claiming insurance reduces by 75.9%. So people will try giving like more loan to those persons, more insurance to those kind of persons. So will target those customers who have more number of children. Similarly, BMI, if you see, with one unit increase in BMI, somebody claiming a insurance is increasing by, the odds of somebody claiming a insurance is increasing by 29.2%, right? Which is a very big number, right? So this is about the interpretation. Then odds ratio, if you see, uh, smoker 0 versus 1. 0 means somebody not smoking versus 1. 0.016. Age, because it is a continuous variable. So what we just explained, age, BMI, children. So these are nothing but the odds ratio, whatever is shown here, right? For each 1 unit increase or one number increase in children, you are decreasing your probability of claiming insurance by 75.9%. 1 unit increase in BMI is increasing your odds ratio. Increase in somebody claiming insurance, the ratio of odds by 29.2%. This part, so that will be a, okay. This again, what I'll do, Let me take this whether it will take print. So do one thing, save all this analysis, right? So when we're going through, so I'm not sure whether this sessions will be live till that point. So let me this date I'll put 7th March insurance. So this let me save. Okay. So then we'll run the same model in the some additional information we can get in SAS Enterprise Miner. So we'll run that in the Enterprise Miner also, right? But before doing that, let us do one thing. Go to your files and folders. Okay. Right click here, create a new folder, right? And let's also create them. Enterprise Miner 2022. Okay. Now go to your or wherever you are working on this insurance file, right? Right click that, copy to. So basically I'm creating a separate whatever from now onwards because most of the times we'll be running on Enterprise Miner, right? If I've created already for some folder because for Enterprise Miner, you can use that, right? So created Enterprise Miner. How everybody has done it. Just create a new folder, right click, create a new folder. Sorry, new folder. Then whatever insurance file you have, right? So the last class you must have worked in that insurance file. Copy that to this new folder which you have created. So I have created a folder called EM 2022 and I have copied that file here. Anybody having any problem here? So right click on the folder path, copy the location, copy the directory because that will be required when you are trying to create a library in Enterprise Miner, right? Copy this folder path. Anybody who is having problem opening the Enterprise Miner? So once you click on that Enterprise Miner, one small file called main.jnlp Java file will be downloaded. Double click on that. So once you double click, it will take some time to like run that SAS Enterprise module, and it will take maybe a few minutes to open the SAS Enterprise module. So go to your main screen. So if you have not done that, do it now. Go to the where is that screen? So we are till now from the last few classes we are running SAS Studio, right? From now onwards, from next class onwards, mostly we'll be working on Enterprise Miner. So click this Enterprise Miner. If you click one, small file will be downloaded in your laptop or desktop wherever you are working. Then double click on that. Every time you have to do that. So double click on that file. So it will run. It will take few minutes to kind of have that Enterprise Miner environment. So next class onwards, please by the time you come to class, kind of at least have your SAS Enterprise Miner open. Anybody who has opened SAS Enterprise Miner?
Yes, sir, it's
Yes,
taking little time.
Yeah. So others, please keep on trying. Anyhow, I'll be sharing the recordings if you're not able to follow right now. Please, but practice it, right? So this is a good tool to have some idea on, and it is very easy, right? Later on, even if you leave practice for 2 or 3 years or 5 years. Once you have an understanding, you can always come back. So enterprise miner. So we'll create a new project, logistics regression. So Apurva and Amok, I hope this screen will be open for you, right? Others, anybody else was open? So click on the new project. Next. So I'll keep today's LR 7MR. Logistics regression 7th of March. Next. So basically we created a workspace for our project. Now what you have to do, you go and click on this program editor. So symbol is this running man. Click on this. We'll just write 2 lines of code, not more than that. Earlier also I have shown you, right? We are creating a library. So this is one thing like academic, because we have this academic usage, right? Otherwise, if we cannot directly use some file from our laptop or desktop, we have to upload. Anytime we want to work on enterprise miner, we have to upload the documents, upload the file in the SAS studio. From there only we can access it, right? So in this particular, yeah.
My enterprise miner is not opening.
So what it is fine.
Sir, it's showing the file is getting downloaded, but it's showing that there is no such app for that file.
No, just double click it. Even if you double click, you need not have to right click and open it. Double click it, so it will run in the background.
Sir, I'm trying.
So even if you double click, it is what it is showing, and no application is available.
Yes, sir.
Okay, do one thing. Go to the SAS site, and so there will be some called JRE, Java Runtime Environment, right? Make sure that you have the latest version of Java installed in your laptop or desktop. So when I say latest, necessary for this is SAS Enterprise 15.1. So if you search in Google what kind of Java runtime environment is required, so it will show that. So you have to download the Java runtime environment. I'll do one thing. I'll share the document what kind of Java runtime environment, because most of our laptops has been updated with Java runtime environment. But you should have that. You might have an older version, might be. So that
Yes,
might
sir.
be one. That might be one issue
Sir,
which
the
I'm thinking.
same problem is happening with me also.
Okay. Okay. Okay, let me do one thing anyhow. Let me go through this today, and I'll share the document what kind of Java runtime environment you have to download and install in your laptop, right? So if still it is not happening, we'll see what to do, right? I think that might be one big issue, because if you do not have the correct Java version, it will not run. So write lib name and whatever directory path for you it will be different, right? For you it will. So this is my SAS ID. For you, your SAS ID will be different. So in my home directory, in my this user ID path, I have created this EM 2022 folder, right? So what I'm telling, leave name, okay, I have to give a leave, right? So SAS or enterprise miner 2022. So what I'm telling SAS enterprise miner, create a library of name EM 2022 and link that to where you will get the data from. I have a directory in SAS Studio. From there you get your data. So create a lib name. So create a library named EM 2022 and get this data from this directory, right? So for you, lib name, you put some name, then put the directory path, then semicolon, below that run semicolon, right? Just click on the run symbol. So if there is no error, means that library has been created. right? So how to know that your library has been created? Go on data sources, right click on data sources, create data source. Now we will go and fetch that insurance data, right? SAS table, next, browse. So if you see this library has been created, double click it. So this for me insurance code data file is there. For you, whatever that insurance file name, right, should be there. Amok, Apurva, or anybody else who has opened SAS Enterprise Miner, are you in this page or are you having any problem?
Sir,
Sir, I
this
have
page
a
only.
so I have a
Uh,
question, sir.
Yeah.
So the insurance 4 folder that you have created over here, is it, matlab, what is the extension for it? Just table? So like we had extensions over there, like CSV had to be converted to SAS Studio files.
Yeah,
In
here you
case.
cannot convert. Here actually you have to convert in SAS Studio. So this is
Okay,
a
sir.
SAS 7.pat. If it is a CSV file, it will not show. So every
Okay, sir.
conversion has to happen in SAS Studio. So if it is a SAS readable file, only it will show here. Otherwise,
sir.
if it is a CSV file, it will not show. Yes, Amok, what you were asking?
No, sir, it was getting hanged. Now it is okay.
Okay, okay. So now what we did, we created a library in SAS Enterprise Miner, and we said that fetch the file. So when I say fetch the file, it can be only a SAS file. If I have, let's say, CSV, Excel, or any other document, SPSS file, SAS Enterprise Miner will not be able to read it. So I have to convert that in SAS Studio to a SAS readable file. Basically, I have to run it. If it runs in SAS Studio, it will convert that into a SAS 7.bat file, right? So once it is done, now that file will be available for me. So I put OK. So what is my table name? So in the library EM 2022, there is a file insurance 4, and I'm going to work on that. For you, it will be something, some other file might be, but again, that same data will be. Metadata. So if you click here, then this is the problem which I was telling about. Not a problem. So if your data is so there is certain kind of a limit of what kind of data can be analyzed. Again, those limits also, boundaries also you can change. So what it is, it's then missing percentage threshold is 50%, right? If for any kind of variable, let's say there is a gender variable which is written in our case sex, 50% of the data set, 50% for the data points, there is no, it is blank, right? So it might reject that variable. Or for, let's say, whether somebody uh, claimed or not, or any kind of variable, number of children, the smoker or not. If 50% of the data is missing, the variable itself will be rejected, right? So rather than 50%, I can make it 20 also, right? And so these are percentage of threshold. What it means is, if 20% of your data for that particular variable is missing, the model will reject that variable from your analysis, right? Class labels count threshold, right? So for a particular category, how many labels can be there? Like in case of your gender, it is only two labels, right? Male or female. Smoker, whether somebody smokes or not. Insurance claim, whether somebody has claimed or not. It can be very large, like state. In our case, I think there are 23 or 24 states which is listed in this data, right? So if you see class level count threshold 20, I'll show you how it, so I'm not changing this, and I'll show you later on how it impacts your model. Detect class labels, it will read how many class labels you have and accordingly analyze. If it is more than 20 labels, right? In our state, I think it is more than 20, then it will have some impact on that. Reject labels count threshold. If it is more than 20, it will reject. Reject variable with excessive class values, database pass through yes. So I did not change, I only changed the missing threshold, though we do not have any missing data. So 50% is a high value, so I changed that to 20. So this is the, again, if we miss it here also, later on also we can identify what kind of like a role the each variable is going to play, but it is better in the beginning itself we are doing that, right? So what time want to predict whether somebody is claiming insurance or not, right? So first part is whichever is your response or outcome variable, identify that and change that to target variable, because I want to target whether somebody will claim insurance or not, right? So I'll change that to insurance claim into target. Then gender is input variable, binary. Smoker is input variable, binary. The number of children input variable. Actually, children is your interval data, right? Number of children 1, 2, 3, 4, 5. It is interval data. Charges, actually, I do not require charges for my model, right? So what I'll do, I'll put it as rejected. I do not require this model. I do not require this variable for my model. So I'm ignoring it in the beginning itself. BMI input variable interval, it is already selected. Age input variable interval. So see, state rejected, it is already rejected. Why it was rejected? I have not done it anything here. If you remember, so we had put a threshold of class level as 20, right? Because state variable, the variable name state has more than 20 labels, it automatically rejected it, right? If I change that to 30, it will not reject it here, right? Profit also I do not require profit because that is not in prediction or not in independent variable. Longitude also not required.
Sir, I have a question.
Yeah.
Sir, you said that the state it got automatically rejected because we had set the threshold at 20. So why did it not reject latitude and longitude automatically?
Latitude, longitude, it is taking as a continuous variable, right? That is where if you say class variable, state is a nominal class variable. Latitude, longitude, it is taking as because these are numbers.
Okay,
So
sir.
it model doesn't know that what does latitude. For us, if I say latitude, longitude, we know that it is a location. But for model latitude, longitude, it does don't have identity. It will just read the numbers. It is number. Number means interval data, right?
Okay, sir.
Then this is category. If you remember, category you had created from BMI, right? Whether somebody is obese, overweight, or healthy, right? Because I'm already taking BMI. Otherwise, it will be a multicollinearity problem, right? I'm not taking category. Either one you can take. You can look into the model, taking into category, putting BMI as rejected. So either way you can do it. Okay, so what? So let us try to see that we are taking the same model what we created in SAS Studio. I have the target of insurance claim, right? Then gender is input variable, smoker input variable, both are binary. Then charges are not required in my BMI is input variable, age is input variable. So age BMI to continuous variable. No, 3 children also is continuous. Basically interval variable. 3 interval variables. Then you have 2 input variables, 2 class variables, categorical variables. The other class variable of state got rejected. So this is one interesting aspect. Today we are not going to use it, but later on in our class exercise we'll use this. So if some of you have used this Excel solver, right? So there for each of your decision there will be a weight associated with it, right? Let me show you what we mean by this. Yes. So there are few things we have to understand here. What does mean by prior probabilities? So prior probabilities of that event, right? So what is my event? So there are 2 levels, 1 and 0. 1 is somebody claiming a insurance. 0 is somebody not claiming a insurance. So from the data what I've given around 1330 like data points, right? The model itself is calculating the probability of that event happening, right? So probability is nothing but frequency of event happening divided by total number of events, right? So 783 is, so out of all these customers, 783 customers who have claimed, right? So if I calculate probability 783 divided by total number of customers. So that gives me the prior probability. So from my sample data, this is the probability which is model is able to identify. But it might not be the true definition, true kind of representation of your population. In population, so in this sample, what happens? You have 58, around 60% of the people who are claiming health insurance or whichever insurance for this model we are taking. But in actual scenario, maybe 70% or 30% of the people who are claiming insurance, right? So if I want to change that, I can put a adjusted prior. I can say that no, this is not the correct representation of my population. Adjusted prior is, let's say, 0.7 and 0.3. So what it means is model will adjust to the population, saying that okay, no, out of this 1300, it is not that whatever 58 and 41. This is basically 70 and 30 or 80 or 20. 80% of the population, which is too much again. Let's say 70-30. 70% of the population actually who are claiming. But in this particular case, we're not changing that. We'll keep that. Let us assume that whatever the model shows that okay, this is the percentage of people who might claim and these are the percentage of people who might not claim, right? This distribution remains same. This basically the distribution of your events, right? Whether somebody will claim insurance or not. Then decision. So what basically decision means, right? If the event happens, one happens, so what is the impact of that, right? So at the end, what we are trying to do for this model, either we can predict that whether somebody is going to make insurance claim or not, or we can also run this model to understand if that person is claiming, what is the impact on us. So generally, if somebody is claiming, so there are two ways, right? There will be certain claim amount, right? So average claim amount, let's say 10,000 rupees or 20,000 rupees. So that is the cost variable attached with this decision one. Decision means if that person is claiming that event is happening, what is my cost variable? So I'll put a constant and say that okay, this is the number, whatever number I want to put. But in this particular case, I'm not trying to find out that later on when with this market campaign. Generally, where you will be using this, let's say you were trying to predict some let's say you have some marketing promotion, right? And based on, in this particular case, we do not have that data, right? We do not know how much money you have spent on advertisement marketing campaigns. So the idea is we are putting some money on marketing campaign. If the person responds, right? If the person takes our subscription or takes certain product from us, right? So the person purchasing that, right, it has a impact on our business, it has a profit on our business. If we are putting a lot of effort, lot of money on that person, but that person doesn't buy anything from us, doesn't take the subscription, it is actually loss to us, right? Why it is a loss? Because we are putting some money for individual customer. If I divide my total marketing budget, let's say it is 1 crore, and I am putting those emailers, website content to 10 lakh customers. So that means for each customer, I am spending 10 rupees. But out of 10 lakhs, only 2 lakhs responded. That means for those 8 lakhs, whatever money I spend in marketing campaign of 80 lakhs rupees, that is just a waste of money, right? So this is what where you have to put your cost variable. Like if the decision is one, if somebody is actually purchasing from us, that is actually they're giving us profit, because obviously we are only spending 10 rupees, but on an average they might take a subscription of 200, let's say for Netflix, 199 or 249 rupees. So that is a profit. But if I'm putting 10 rupees of advertisement on you and you are not taking a subscription, so my decision too, if somebody is not subscribing, so I have a loss of 10 rupees. So that is cost parameter will be minus 10, right? Then what I want to decide, right? Whether I want to, so if I'm just calculating the revenue out of customers. So in this previous case, so when decision is, let's say I want to maximize my, let's say revenue, right? So in that case, what will happen? So for decision one, somebody is, or maximize my profit, right? What will happen? Decision one is somebody will take my subscription. So subscription, average subscription amount is 250 rupees minus 10 rupees of cost. So 250 minus 10 is 240 rupees. So here I'll put constant then I'll change this to 240 rupees, right? If somebody is not taking out subscription, that is constant, but what is my loss? Actually, I'm putting -10 because 10 rupees I'm spending, but he is not taking my subscription because I'm getting 0 rupees from that person. That is -10 rupees for me. So then I'll come back here and say that what I want to do. I want to actually maximize my profit. So this is one way. Other way around is what I want to do on minimization of cost. Let's say for decision one, my total cost was whatever. In this particular case, actually I'll put 0. For decision two, it was 10 rupees. Then I'll go and say that okay, minimize now. Minimize the total cost, because in the decision one, somebody who is giving me like kind of a business taking my subscription, I'm okay with that. But for the other person, other like group who are not taking my subscription, I'm losing 10 rupees. So I want to minimize that, right? So these kind of additional analysis also we can do, but in this particular case, we are not doing that. We'll go back and make sure that these things remain same. Next, no. So I have total 1338 rows. Data partition. So anyhow, we'll do that in data partition, not required here. Next, finish. Okay. So this is one step. So next step is just copy this code what you have written. Go to this project. Just click here in the project start code. Copy paste. So this is the additional step. This generally doesn't record in the corporate version. I'm not sure why it is asking in the academic version. But anyway, without that you cannot run. So in the project start code, you put and run. Once that is done, so I have now data sources. I have to create diagram. Right click on the diagram, create diagram. LR 7 March. Okay. So now the analysis part will start. To carry out the analysis, first step is to click on this insurance data set, drag it to workspace, right? So first step, what we have to do, you have to do a data partition. Click on this data partition, drag it here. Link this insurance to data partition. So how do you want to divide your data set, right? Either training, validation, test. So let us divide into 70, no validation, test is 30. What is taking validation 30? So data partition, then what we'll do, we'll run a model regression. So first step is we drag this insurance file, then we'll make a data partition of training data and test data, then we'll run a regression. The regression automatically it is selected logistics. So because outcome variable is a binary variable, so it is almost already automatically selected logistics. We did not select. I can change it to linear, either logistics or linear, but obviously this is a logistics regression I want to run. So right click on this and click run. First we'll make this training and test data set. Then we'll go to the regression, right click it and run. So additionally, if you see some additional plots has come, let me just share that screen. So there is something concept called leaped gain chart, cumulative leap. So this we'll discuss. So this has a lot of importance in this kind of marketing campaign prediction, insurance claim prediction, because think about as a sales or marketing team, right, or product management team, the amount of money they spend in product introduction, product launch, marketing, sales, right? So the idea is they will be able to target those customers from whom they'll get better response, right? Otherwise, if randomly they try to put emailers, advertisement campaign, these are complete wastage of money, right? So this is where this kind of we'll discuss in detail what does leap and gain means and how you are going to use this, right? So again, like if you remember, these are the few statistics, few like kind of comparative statistics to error function, maximum absolute error, mean square error, AIC value, right? So to compare how does your model does in training and testing data set, right? Average square error, average error function, misclassification rate. So this is something which will also come from the classification table also. So let us see that whether we get a same model or not. If you see, it is almost age 2.94 percentage, BMI 28 to 28.4 percentage for each person who is smoking, right? Your claim reduces by around 86.4 percentage for a person who is female, right? But again, if you see, this is not a significant variable, right? So this is, if you see, remember in our SAS studio, gender was not taken as a predictor, right? It was already removed. Why it was removed? Because if you see, the probability value is p value is 0.58 5180. Ideally it should be less than 5%, right? That's why it was rejected. Else. So this is a event classification table: false negative, true negative, false positive, true positive, right? Can anybody tell me what does it mean? True positive, false negative, and false positive. So what is type 1 error? What is type 2 error? So out of all these four, which is a type 1 error and which is a type 2 error? True negative, true positive actually is good, right? Because whatever the true nature of the data, true nature of predictions, it is not event. That means somebody has not claimed. We are able to 331. We are able to true negative. That means there are 331 respondents who have not claimed, and we are able to predict that correctly. Truly they are negative. That means truly they have not claimed. Similarly, true positive. That means 495 people who have claimed, and my model is able to identify them, right? So that is also good. Then what is about this false positive, right? What does the actual meaning of that?
Sir, in real, it was not claimed, but the model showed that it is a positive case.
Yes. So if you see, our main event is whether somebody is claiming or not, right? In our case, positive, it is identifying if some event is happening. For us, the event we have identified is whether somebody is claiming or not. So in this false positive, what is showing? The reality they have not claimed, but our model is showing that they have claimed. So there are 58 false positive. Similarly, false negative in our case, negative means that event has not happened, right? So 52 people are there who have not claimed, right? But it is showing they must claim. So that is a false negative. So our model is showing them that they have claimed. So that is a false negative, right? So this is something again we have not discussed the classification table, right? So this is this from this data set only they are putting that lift and gain that curve what you saw that gradually it is declining, right? So from this data set it is only saying. Anybody who has idea what does it mean? We are not getting into the mathematical part, anyhow we'll calculate that. But what does this leap and gain means theoretically? Anybody who has any idea? So basically, see what we are trying to find out. We are trying to find out from this modeling or whatever we are going to do. We want to predict something. So predict those customers or predict those respondents, right? Whom we will be able to better target, right? So these things will be actually useful when in the next class exercise you do some marketing campaign prediction, right? In this particular case, because it is a hypothetical data, some numbers might not show the actual result. But think about a scenario, right? You want to launch a marketing campaign for some banking customers so that they take a loan from you or they take some credit cards from you, right? So what is your marketing cost? So the amount of money you like, obviously email is not email or WhatsApp, though it looks like it doesn't cost. For a business, it costs money, right? So they might send you email, they might send you WhatsApp messages, they might call you. Most of the times at your home, you'll be getting call from different banks. Sir, take this credit card, take this loan. Those are also cost. It might be very minimal, right? Per customer, they might be spending overall 10 rupees, 15 rupees, or 20 rupees. But if you calculate that per number of customers, there are 50 lakh customer or 5 lakh customer, 20 rupees means 1 crore on this marketing campaign. For each customer, even if they are spending overall 20 rupees on email, WhatsApp messages, phone call, 20 into 5 lakh customers is 1 crore rupee money they are spending. So how these prediction models are going to help us? If rather than those all 20 lakhs, because right now what happens? So they launch a marketing campaign last year. So it identified, let's say how much, 5 lakh customers, and 5 lakh customers were targeted. 20 rupees each was spent. So to overall 1 crore rupees. But out of those 5 lakhs only, 50,000 responded means 50,000 came to credit card or took a loan, right? So overall, if you see your like that marketing campaign, how much it succeeded out of 5 lakh customers, 50,000 means 10%. 10% actually is a very good number, right? Ideal scenario, 5% to 10% is a very good number. So let's say 50,000 people responded, right? Now think yourself as a marketing manager. I send these marketing campaigns to 5 lakh customers spending 1 crore rupees. Out of that, only 10% people responded. That means only 50,000 people. Is there a way I can predict or I can find out those target customers in a better way so that rather than targeting 5 lakh customers, I only, obviously, I cannot find all those 50,000, right? But at least I can reduce my target from 5 lakh to 3 lakh or 2 lakh or 1 lakh, and I'll increase my success ratio so that rather than targeting 5 lakh customers, if I'm able to find out those people, those type of customers, if I send my emailers, WhatsApp or call, they'll respond and they'll take a product from me, either a bank loan or a credit card. So all of our prediction model, which we are going to discuss in next, including this logistic regression, is kind of way towards that, right? So the idea is to how to predict or how to find out those target customers for whom if you send your marketing campaign, they will respond positively. So all this lift and gain chart actually helps us doing that, to find out those type of 5%, 10% of the customers where your lift from the normal. Lift means how your model, or are you able to identify those individuals, those group of people whose response is much better. So in our case, in the marketing campaign, what I'm talking about, lift will be basically if they are able to respond, if they're taking our product or buying our product or subscribing to our product. Am I able to identify those 5%, 10%, top 20% of the people? So when I say identify basically those type of people, maybe female age group this 25 to 30, recently like kind of got into this job, right? With those parameters, with those profile, I'm able to identify whether they'll take a second credit card, right? So that will be lift from the baseline. Baseline is I'm targeting all my 5 lakh customers. But if I'm able to identify those 5% or 10% of the customers who are going to actually respond in a better, right? In earlier case, my baseline leap was baseline value was 10% only. My target is to improve to, let's say, 30% or 40%, right? So from my baseline performance was 10% response rate. My target is to take this 10% to 30% or 40%. How will I do that? If I am able to predict somebody's response better way, right? Earlier, what used to happen? Okay, I have a list of 5 lakh customers. To all of them, I'll send my emailers. To all of them, I'll call them through call center and try to offer them my credit card or bank loan. But through this predictive model, I'm trying to find out, rather than sending to 5 lakh customers, let me send to those 20% customers who have much more probable to respond to me, right? So this is where your lift and gain will be helpful, right? We'll discuss this calculation. How do they get these numbers? How do they arrive on these numbers? But again, save these files. We'll be again discussing this. Yes, save this. Now try this out. It. Okay. So Amog and Apurva, have you raised this results document? Or are you
Yes, sir,
stuck somewhere?
opening. Sir.
So others, I think, who are Subham and Abhijit, you had issues. So I'll share a document to download this Java runtime environment. If just check that, and there is a process where you can go in your command prompt, not in command prompt, in your Windows Explorer, you can go and see that which kind of Java runtime environment is available. If the environment is not matching as per the requirement, right, you will not able to run. I'll share that document, go through it, and accordingly download the latest.
Sir,
Yeah. Go on, go on.
sir, sir, in enterprise miner, there is a configuration steps requirement. So I have clicked that one, and they are suggesting the Java files, and they have written the current version of Java is available here, the link, and I have clicked that one. And there is 3 files, which one I have installed, that x64 installer. So after that, installing that file, yes, after installing that file, still there the file is not opening. मतलब वो main, and then
Yeah. So
dot
once you install, okay.
JNLP जो
Yeah. So you have to restart, because what happens, it always take the file from the cache. You have to clear your cache, right? So do one thing, after this class, restart your laptop, right? Otherwise, what will happen? It will, the previous Java NLP file will be still running. Unless it is cleared, you will not able to run the new file which you are downloading. So after this class, restart. If it is still not doing, then we'll see.
Oh, okay, sir.
Okay. And Soham, please do same thing. Soham, I don't think
Yes,
he's
sir.
there.
Yes, sir.
Yeah.
Yes, sure. One second.
Oh yeah, Shubham, please follow the steps. If still not happening, I will share the document. I think Abhijit already found out that. If still not working, we'll see in the next class. Okay. So just quickly, just give me 10 minutes to quickly discuss few of the slides. Okay. So logistics regression running using SAS Studio and Enterprise Miner. So there is something, if you see, there is something called a generalized linear model, or GLM, right? So if you saw that there is GLM coding, reference cell coding, effect coding. In your tasks also, there is something called binary logistics regression, GLM model. So GLM means generalized linear model. So how it is different from your linear regression or linear model? So in your linear model, we are predicting a continuous variable, right? And we are assuming that that continuous variable is following a normal distribution, right? The response probability distribution need to be a normal distribution. If it is not normal, right, like in this particular case, it is a binary distribution, right? Binomial distribution, or in sometimes it can be a Poisson distribution. You are trying to find out count data, right? So in those cases, obviously you cannot run a linear regression, right? So in those particular cases, when your dependent variable, right? Is not a continuous data, right? So the model what we are using is generalized linear model, right? We are still trying to use the linearity equation, right? If you see the right side will be still a linear combination of beta 0 plus beta 1 x1 beta 2 x2 and matching it with our output variable, right? Whatever our outcome variable, right? So generalized linear models are an extension of traditional linear model, which is our normal, no, basically linear regression, right? Multiple linear regression. The response probability distribution, that is our dependent variable or outcome variable, can be any member of exponential family of distribution, right? So I've shown some of the distributions. So whenever you have normal, right, you generally run this linear regression, right? But it is not necessary every time your dependent variable will be normal or close to normal, right? It can be anything. Let's say your warranty data, number of items for a Maruti automobile company, they do this kind of viewable analysis. Reliability of your parts, reliability of your components. So how when that item is going to fail, when this component is going to fail. Imagine why it will be necessary for a business, because accordingly they will number of parts, number of items they source from their raw material manufacturers will be required. So in those kind of scenario, your data itself, though it is a continuous data, when that it is the event when that components or parts are going to fail, number of days it will take for a part to fail, but it is not a normal distribution. It is something known as viewable distribution. Reliability analysis, it is required for reliability analysis. So in those particular cases, you cannot run the linear model, linear regression. You might have to run something called generalized linear model. So that is where you use viewable analysis. In our case particularly, right? Whenever you are binomial data or like kind of a, you have this nominal, ordinal, or let's say your binary data, right? We are using basically logistics regression, right? Those all these models, what we are discussing, whether logistics regression, nominal regression, or viewable analysis, right? All these will fall under generalized linear model. Why it is generalized linear model? Right side part of the equation, we are still keeping as our linear combination, right? A probability. So what does mean characteristics of a generalized linear model? A probability distribution describing the outcome variable, right? A linear model, that outcome variable, the combination is a linear equation, right? So like a equation of a line, y is equal to slope multiplied by your variable parameter, right? Then there is something called a link function, right? So this is, if you see in our linear regression, so the link function is nothing but your identity function, that because that value itself. So what we want to predict or what we are trying to find out, that is our outcome variable, that is our y, that is our response variable or the dependent variable. That itself becomes your link function. There is no equation, there is no function. But in case of logistics function, what actually we are finding, we are not finding the some number, some value. What we are trying to find out is the log odds ratio, logarithm of odds ratio. Then what is odds ratio? I'll show you. Then log linear is log relative rate. There is something called proportional hazard model, right? So that is mostly used in this kind of whenever an event is going to happen, right? Let's say you are constructing something or you are like kind of processing certain material, when these components will fail, or in this kind of sometimes they do this kind of simulation models, right? In this kind of conflict, let's say what I'll say, businesses grow and for economics. So one, what they want to predict, when these businesses will going to fail, when these models are going to fail. So that is where the hazard means the event of failure, right? So in this case, they take the unit function or the like identity function is log hazard, right? Uh, okay, analysis framework where to use logistics regression. Whenever you have type of predictors is continuous or categorical, right? So predictors is your independent variables, right? It can be either continuous, like we saw right now. Insurance, we want to predict whether somebody claimed or not, right? So your predictors are age, your kind of number of children, BMI, those are continuous variable. Then also we had categorical variables. Categorical variables were kind of whether somebody is smoking or not, whether somebody is a male or female, right? So when your predictors are continuous and categorical and your type of response is categorical, then ideally you should use logistics regression, right? When you are continuous, you have a type of predictor continuous, right? And your type of response is continuous. Generally, we will be using ordinary logistics, or sorry, OLS regression, right? So that is your linear regression, right? So then the case is, why not in this particular case the response variable was binary, right? 1 or 0. Why you cannot use a this ordinary least square, right? So the point is, why we will go and create a odds ratio, odds probability? Why get into that complexity? Why I cannot say that we'll create a linear equation? I'll say that okay, whether somebody has claimed 1, somebody has not claimed 0, then I'll predict and measure the distance. Ordinary least square is what? We measure the distance from prediction. So I say, okay, I predicted 1, somebody said 0. Or I predicted that person will take insurance, but actually he did not take. So difference is 1. Similarly, either what will happen? I predicted that person will not take insurance, but that person took insurance. 0, 1. Or it can be true also. I predicted 1, it happened 1. I predicted 0, it happened 0, right? So I can do also that, right? I take whatever I predicted and whatever the actual value, take the distance and try to minimize that. So what will be problem will happen in that case?
So there will be chances of high residual error, and the line will also not fit. So for that we do not
Yeah.
take that. We do logistic model, the inverted S shaped or inverted, whatever the
Yeah.
case it will.
So basically the model, it is not that you will not able to feed the model, but the model error will be so much that rather than creating a model, you can just take like whatever your baseline model, based on your intuition, you can say that whether somebody will take the insurance or not, right? So it is not that we cannot fit a ordinary least square model. It will still, like, I can put any number and it will fit, but the result will not be like, let's say in the response is coded 1 or 0. So at the ordinary least square, what happens? I'm predicting something, right? So let's say the number came as 0.4 or 0.49. So whether I'll take it as 0 or whether I'll take it as 1, or when it comes as 0.55, well, what should I take? Whether it will be close to 0 or close to 1, right? Because my prediction is not about the number, some continuous data, continuous number, right? So first the model I can feed, but model will be error. Some second, even if let's say I'm using that model, at the end it will give some, if I create that equation y is equal to beta 0, so this equation what is written, it will say that okay, I have all these variables, it came as 0.56. Then what does this 0.56 mean? Whether that person actually will take loan because it is close to 1, or whether that person will claim insurance because it is close to 1, or that person will not claim insurance, because I'm not interested in that 0.56. I'm interested whether I can predict with these parameters, with these characteristics, whether somebody will claim insurance or not, right? So this part I think I have already explained in the beginning. Yes, logistics regression can be run whenever you have multiple groups. If the groups are nominal, like I said, if I want to predict out of all those 300 of you, 300 students who are fit for HR roles, who are better for marketing roles, who are better for analytics roles, right? So that kind of research or that kind of prediction also I can do, as long as I have good amount of data. Or I can do a ordinal. Let's say no interim happens, and based on your past data, I want to predict which kind of grade you will get, right? Then actual when the interim happens and you have the final grade, I can kind of validate my model. How well did my model work, right? So just imagine the scenario based on your past kind of uh, performances, right? I'll predict for each of you. I'll predict what kind of grade you will get, right? Then actual when it happens, then I can do a classification table and understand that how many true positive, true negative, all those classification table, and say that how many of them were misclassification, right? So if my model is performing well, so that means I'm able to predict that better, right? So again, but the complexity of parameters becomes little difficult, right? So most of the times we use binary. Sometimes economists they use different type of model also, nominal logistics regression, ordinal logistics regression. So odds probability of event happening divided by probability of event not happening, right? So if I want to predict whether, let's say this, what is happening, let's say India Sri Lanka test series is happening, whether batsman Virat Kohli or Rohit Sharma is going to score a century, right? So event of somebody scoring a century, that is event happening, divided by not scoring a century. So that is the odds ratio, like kind of how much like kind of this stock will rise, right? Or stock will rise, tomorrow it will rise, but tomorrow it will fall, right? So what is the probability that stock will rise? So let's say it is the probability that tomorrow there might be ceasefire, Russia might be putting ceasefire or some kind of agreement negotiations are happening. So that might be good results for Indian stock market. So there is a 80% chance that the stock price will increase, right? Or stock price will move up. So 80% is what is the chance that it will stay same or come down? 20%, right? So what is the odds? Odds is good. 80% divided by 20%, 4:1, right? So at the end, what we are trying to do is that using this mathematical formula or using this mathematical concept, and we are utilizing that in our study, right? In our research, in our prediction. What we want to predict, whether somebody will claim insurance or not. So if that person's claiming is, let's say, I can predict 80%, not claiming is 20%. So whatever, 60%, 40%. So for that person, for that individual, the odds ratio is 60% divided by 40%, 1.5. So the idea is uh, how I'm able to kind of manipulate or use my independent variables. Am I able to find out these independent variables, which will help me to predict this odds ratio, predict this number that, okay, by, let's say, if somebody is a smoker, somebody do not have children, somebody who is male is more likely, more probable, or more odds of claiming a insurance. So I should stay away from those customers because they are going to claim. So whatever charges they are going to give me, everything will go. Once they claim, they'll claim 5 lakhs, 10 lakhs rupees, right? If it is a health insurance. So I should stay away from those customers, right? So that is how we are going to use this. So our logit function is nothing but logarithm of this odds ratio. Odds ratio, like I said, probability of that event happening divided probability of that event not happening, right? So why it is a generalized linear model? Because right side of your equation, left side of the equation is the link function. Link function in case is a logit function. So logarithm of probability of event happening divided by probability of event not happening. That is the left side. In your linear regression, what used to happen? That is identity function. That is only the there is no probability. That is the continuous value. That is a whatever. Let's say I want to predict profit or I want to predict claim amount. So that will be in the left side, and right side obviously this linear combination. But in logistics regression, your right side still remains same, some linear combination, right? Left side, rather than that identity equation, we were trying to predict the odds ratio. So logarithm, so logit function is logarithms of odds ratio that will come in your left side, and right side remains same. Right side is a linear combination of your predictors. That's why it is a generalized linear model, right? Still it is a linear model generalized with your link function. Link function is like for your logistics function, it is a logit. So okay, so just give me how much time is left. Okay, time is almost over. Okay, we'll do one thing. How much slides have 10 slides. Okay, another 15 will do one thing. I'll share the slide, go through it, and I'll share the recording also. If some of you, like some of you, are not able to download Java and run Enterprise Miner, go through it, and we have downloaded the output, right? Next class, what we'll do, we'll quickly go through this kind of categorical coding. Then directly we'll get into uh, how we interpret this kind of results, right? So there are different, like we did it for linear regression, there are different parameters which helps us to interpret results, right? So this anyhow, I think most of you know. What will be interesting for us to understand this statistical significance, then I think AUC, I think most of you know. Comparing pairs, that I think it will be little new for you. And lift and gain chart, right? So this is something which will be important for us, how we are going to use this, right? So this is our task for the next class. We'll discuss these slides. We'll go through the results what we have got today. Then we'll do a class exercise for the marketing campaign prediction. Okay. Any last questions before we close?
So how do we treat the errors in logistics regression?
Errors of what? Errors through
So
your
like we
classification
had,
table, right? So there is no error as such.
yes,
There is only misclassification, right?
okay, sir. So like
Because
we had in linear regressions, we had the bias variance and overfitting,
yeah, no,
underfitting.
here you create that classification table and you try to see that whether you will be able to reduce this false negatives and false positives, right? The idea
Okay,
is
sir.
because see that is the misclassification. That is what is kind of wrong in your model. Like in your linear regression, that is the error difference from the prediction with the actual outcome. Here, it is the misclassification, right? So there is no as such error because error means the difference between prediction and outcome. Here, basically, you have to classify something, but you are classifying it incorrectly. So I'm classifying somebody who is claiming insurance. I'm classifying that person will not claim insurance. For somebody who is not claiming insurance, I'm classifying that person might claim insurance. So that is the error in my model, right? And that is how I'll try to reduce it.
So, sir, in
Finding
case where we don't reduce the errors, we focus on increasing the accuracy of the model.
yes. So like I said, we'll try to improve our lift, our gain. I will try to find out where our model works better.
Okay, sir.
That's all for today. Abhijit, Subham. Anyhow, I'll share the document for the Java runtime environment, but please restart. Sometimes what happens if the that Java cache is still there, it will be still running the old file, right? And if still not working, then we'll see in the next class. Okay.
Yes, sir.
Chalo, take